last machine that we will be tackling today is the milling machine. I know most of you don't have a thorough idea of what a milling machine is. That is why I, together with Mr. J.V. Villadel and Ms. Nadia de Manil, will be discussing milling machines, operations, and heads. A milling machine is basically a power-driven machine which functions on removing a material from the workpiece. This machine is widely used in manufacturing processes for a variety of shapes and features, which are done through the rotation of multiple tooth cutting tools.
And using this machine, one should always practice safety precaution. Milling machines are sharp cutting tools and may pose serious injuries. Yet, despite these hazards, milling machines are widely utilized with its array of function in the modern day of manufacturing. An operator must be knowledgeable of the parts of a milling machine. This includes the base, the overarm, the spindle, the knee, the table, the saddle, and the column. The base provides support for the other components of the machine. The overarm is the horizontal beam that supports the spindle head. The spindle is the rotating shaft that holds the milling cutter. The knee is the movable component that supports the table. The table, it is the surface that supports the workpiece and can be moved on both axes to feed the workpiece. The saddle is the movable member that is attached to the knee and supports the table. Lastly, the column, it is a vertical member that supports the spindle head and knee.
With a lot of functions and workpieces to work on, we should also take note of the various types of milling machine. These machines include knee and column, plain milling machine, universal milling machine, and vertical milling machine. The knee and column milling machine is the most common type of milling machine, named from the knee and the column structure. A plain milling machine, meanwhile, or a slab milling machine, or a surface milling machine, is utilized on flat surfaces and large workpieces. The universal milling machine, on the other hand, from its name, are machines that can perform any task from flat surfaces to complex shapes. Lastly, vertical milling machine is a vertical-oriented spindle. To adjust the depth, the spindle can be changed on levels and move the workpieces on both X and Y axis.
Aside from knowing the machine, an operator must also be knowledgeable on the safety precautions. This is to avoid any accident or damage on the machine itself. Here are some suggestions from Brown and Sharp Manufacturing Company. Anticipate the actions to take place before moving the operating lever. Never play the control levers or carelessly turn the handles while the machine is stationary. Do not lean against or put hands on a moving component. If necessary to do so, identify the direction in which the component is moving. Ensure that the work, if held securely in the fixture, and the holding member is fastened to the machine table before performing cuts. Remove chips with suitable instruments and never with bare hands and fingers. Study the milling machine thoroughly to devise accurate plans and actions when certain emergencies arise. Keep distance with the milling cutter. Avoid touching the cutter even if it is stationary. If suggested to do so, do it carefully.
Before running the machine completely, preliminary operations should be done on the milling machine. This includes cleaning the machine, oiling the machine, and mounting the workpiece. The importance of a clean machine holds much significance and cannot be emphasized too strongly. Machine's accuracy and durability depends on the level of maintenance and cleaning an operator is doing. It is suggested that milling machines are cleaned regularly before and after usage.
Oiling machines cuts damages on the milling machine. Few drops applied regularly is very much needed to safeguard the mechanical condition of the milling machine. Modern machines are equipped with automatic lubricating systems, which should be maintained in its finest state for better function.
Before operating the milling machine, securely positioning the vise to the table is needed. There are various techniques on mounting the workpieces. These include on the table, in a chuck, on an arbor, between tenters, on fixtures, milling machine vise, and clamping devices. There are also certain methods on aligning the vise jaws with the column, which are to the indicator, parallels, and with a square.
Aside from preliminary operations mentioned above, properly selecting a milling cutter that is suitable on the job to be done obtain great results. Common milling cutters and their applications. Double angle cutter, used for fluting taps, reamers, and so on. End mill, suited for surface milling, profiling, slotting, and so on. Fly cutter, can be used to mill intricate shapes that do not warrant the expense of form cutters. Form cutters, used to cut curved or irregular surfaces, also for fluting tops, reamers, twist drills, and so on. Half side cutter, used for faced milling or in pairs for straddle milling. Helical cutter, especially adapted for thin work or intermittent cuts where the amount of slack to be removed varies. It is not a general purpose cutter. This cutter is erroneously called a spiral cutter. Inserted tooth cutter, characterized by long life, it is used for heavy-duty face and side milling work. Interlocking side cutters, designed to maintain an exact width for milling slots. Nicked cutters, suited for making deep cuts as in roughing work. Plane cutters, used to mill a flat surface parallel to its axis. Side cutter, suitable for slotting operations. Single angle cutter, chiefly used to cut milling machine cutter teeth. Slitting cutter, used to cut deep slots and to cut off stock. Slotting cutter, used to mill shadow slots, such as screwhead slots.
Cutters must also be sharpened to attain satisfactory results. A dull cutter does not last long compared to a cutter in proper condition. Angles are taken into consideration as well as clearance angles of the cutters. Presented are the suggested clearance angles of cutters based from the Cincinnati Millicron Company.
Also be mounted properly to avoid any accident. Mounting this depends on the length of the arbor or the cutter and the support bearings. Cutter rotation should also be considered. It may be conventional, whereas the feed is against the cutter rotation, or climb milling, where both feed and the cutter rotate in the same direction.
The speed of a milling cutter is influenced by the amount of material removed per minute and the relationship between the depth of the cut and the feed. A shallower depth and higher feed allow for a faster speed compared to a deeper cut and a lower feed, although the material removed per minute may remain the same. Now, the rigidity of the machine and the workpiece fissure also affect the cutter speed.
Feeds, meanwhile, the feed rate in milling represents how quickly the work moves past the cutter and is typically measured in inches per minute. In production, the general practice is to maximize the feed that the machine and work can handle. Determining the starting point for the feed rate can be challenging.
Different fluids and compressed air serve to dissipate heat during metal machining, with the choice of coolant contingent on the material being worked. Cast iron, milled at typical speeds and feeds, doesn't overheat milling cutters and should not be used with a liquid coolant, as it creates a sticky mess. Different fluids and compressed air serve to dissipate heat during metal machining, with the choice of coolant contingent on the material being worked. Cast iron, milled at a typical speed and feeds, doesn't overheat milling cutters and should not be used with a liquid coolant, as it creates a sticky mass when mixed with cast iron chips.
Moving on to the milling dividing heads, which are used to rotate a piece of work through angles, commonly on dividing a circle to equal parts. These heads are classified as plane, universal, and helical.
The worm wheel, with 40 teeth, is keyed to the spindle for co-rotation, on which the worm operates with the worm wheel at a 40:1 gear ratio. The index plate contains various rows of holes with different hole counts, easily swappable for desired spacing. The index pin on the crank attached to the worm shaft can be placed in any hole. And lastly, the sector has adjustable radial arms secured with a clamping screw for setting desired angles. Next is the universal type. What sets a universal dividing head apart from a plain dividing head is its versatility and additional features. A universal dividing head stands out with its versatility and swiveling mechanism for cutting gears, flutes, and various tasks at different angles, making it ideal for complex operations.
Lastly, moving on to the helical dividing head. It allows precise and controlled rotation of a workpiece at a constant angle, facilitating the cutting of helical patterns like threads and grooves. It differs from plain and universal heads by connecting the spindle to the table leg screw, enabling simultaneous longitudinal movement and rotation. We also have the dividing head and driving mechanism. With this, the Cincinnati Milacron Company, an American machine tool builder, manufactures dividing heads in 10-inch, 12-inch, and 14-inch sizes, which are used extensively in milling spiral and helical gears, cams, and so on. Accordingly, there are two types of driving mechanisms that can be used on all heads. First, the enclosed standard lead driving mechanism, which is for standard equipment on universal knee and column machines and available for plain and vertical machines. And second, the short and long lead attachment for extra equipment. It is also important to note that there exists such an instruction for setting up of dividing heads and driving mechanisms that are to be followed in order. And that wraps up our brief discussion of Module 8, where we delved onto the concept of planer, shaper, and the milling machine. Thank you for listening.